When net force acting on a system is zero, or when collision happening so quickly that the time of collision is practically zero, the momentum of the system does not change. We call it the law of conservation of linear momentum. We will consider one specific case when two objects collide. In our experiments, it's going to be two cars. They may have the same mass, they may have different mass. We can actually run many experiments because we can measure the velocity, acceleration, and we have special sensors that can measure forces, so we can extract a lot of information. What can happen? Well, anything can happen. They can stick to each other, they can bounce off each other, depending on initial velocity and final velocity, on masses, many different outcomes possible. To analyze a situation like that, first we need to extend our definition. For a single object, a linear momentum equals a product, mass times velocity. So what if several objects are involved? This is our system. Our natural definition is just add them up. If this travels or doesn't travel anyway, it has a linear momentum, m times v. This has its own linear momentum, m times v. If we add them up together, that will be the linear momentum of the system of two cars. And the law says if net force acting on a system is zero, or the collision happens very quickly, the linear momentum of a system must remain the same before and after. For each car, gravity and normal cancel each other out because it's a horizontal surface. Of course, we neglect friction. They travel to each other, they touch each other. After that, they may move, and again, normal force and gravity cancel each other. This situation happens before the collision. This is after. But if we calculate the linear momentum before, P1 before plus P2 before, and calculate or measure the linear momentum after, P1 after and P2 after. This is a linear momentum of a system before. This is the linear momentum of a system after. And the law says they have to be equal to each other.